Mine was almost good. And you're also going to want that z-score chart out, or you can turn in your books to page A16. By the way, if you need a new copy of your z-score chart, that is, there's extra copies in the thing over there. Okay, so is this a left-tailed test, a right-tailed test, or a two-tailed test? And how do you know? Yes, you look at the alternative. You can see how the alternative says that it's less than. So I'm going to draw a little part over here. This is my null over here. This is my alternative. It's a left-tailed test. And it says that my level of significance is going to be alpha equals 0.05. So I need to find out what this z-score is right here that gives me an area of 0.05 on the left. How do I do that? What do I look up in the table to figure that out?
99.
But it's 0.05 and it's to the left. Does the table read to the left or to the right?
Oh.
Left. The table reads to the left, so we're going to look up actually just straight up 0.05. If it was 0.05 on the right side, you'd be looking at 0.95. So everybody inside your table, you're looking at 0.05. Yes, negative 1.645, which should be like a pretty familiar number at this point, right? Okay. All right. So this is the critical value. I'm just going to write critical value. It's kind of like that line in the sand. Over here, this dark spot, that's our rejection region. That means like if it falls over there, we're going to say no good. It's false. I don't believe you. And now we've got to find, and so we also determine the rejection region. So this is like step 3 is right here, and step 4 is just knowing that that shaded area to the left is your rejection region. All right, step 5, now we've got to do the actual formula and see where our stats lie. So x minus mu over sigma divided by the square root of n. Okay, so x bar, that is when they actually did a random sample. Do you see how it says a random sample of 20 of the company's mechanical engineers has a mean salary of this? So that is your x bar. The mu is what the claim was, which was $68,000. Then we're going to divide by the population standard deviation, which is 5,500, divided by the square root of n. What's n? 20. All right, so put this in your calculator. You're definitely going to want parentheses around the top set and the bottom set like this. Yes. Do you have one of mine?
Yeah.
Okay. Yes. It should look like this when you type it into your calculator. I got negative 0.89. Yeah. I suppose you could go, I guess 3 decimal places would be all right. Z equals negative 0.894. All right, so this is my standardized test statistic, negative 0.894. I'm going to write standardized. You don't have to label it every time. I'm just realizing that you don't know any of the vocabulary, right? So this is called the standardized test statistic right here. So where is negative 0.89 on here? Is it in this rejection region over here? No, because that would be less than negative 1.645. And like negative 0.89 is like hitting like right about here, right? This is like negative 0.894. It's right about here. Do you see how it's hitting in this null region? That means that I'm going to accept the null. So the first thing you think about is whether you're going to accept or reject the null. It hit in the null, it didn't hit in the rejection region. I'm accepting the null. Which one's the null again? H sub O or H sub A? O, H sub O. So if I accept this one, everybody look up. If I say this is true right here, what does that mean about the claim? It's false. So I'm going to reject the claim. And then make sure you say a sentence. So reject the claim that the company's employees are paid less. Than $68,000. There are zombies next door, right? There is no type 1 or type 2 in this. Type 1 or type 2 is when your test goes wrong. Like suppose, you see how I just said, oh, the employees were wrong, I reject their claim, but maybe I got like a weird 20 employees, you know, and like I got some weird salary numbers, and so I was actually wrong. That's what a type 1 error is. Okay, so that's how you do this. It's not too bad. We're going to be doing this for the next 2 chapters, only for like chapter 8, it's going to compare 2 populations. So you would say something like, this might be a fun end of the year project for you 3, is to do something like, girls are better than boys at memory games, or, you know what I mean? Or, you know, like you can compare 2 populations, essentially, with chapter 8. Chapter 7 is just one hypothesis test. Okay, we're going to try example 2 together one more time. We need more practice. Example 2, a researcher claims, okay, so number 1, that the mean annual cost of raising a child 2 and under is $13,900 in a random, I don't know why I capitalized in, my bad. A random sample of husband and wife families in the U.S., the mean annual cost of raising a child is that. The sample is 500 children. There's the see it says population standard deviation. I'm going to write it down right here. Population standard deviation is 2,345. And it doesn't say it's normal. But on the first page it said it has to be normal or n has